second part is the experiment. And that's where we have two brothers, and they have plenty of money. So they decide to build a spaceship that will accelerate it when gravity, continuously. So they go out, and this one guy takes off, and the other guy watches them from Earth. And then they have another guy who's their buddy, and he takes off on another spaceship, and he follows the first spaceship. Now the question is, what will happen? And it's my suspicion that if both of these two spaceships continue to accelerate at one gravity, I calculated that it would take a year and 3 or 4 months before they reach 186,000 miles per second from their own point of view. However, for the other guy watching them on Earth, they're not traveling that fast. But if they continue to accelerate, although I don't believe it's generally understood by humans today, what I believe will happen is, from their own point of view, they'll attain speeds of twice the speed of light, the observed speed of light, 5 times the observed speed of light. As long as they keep accelerating, they will keep going faster from their own point of view. But the guy back on Earth watching them, no matter how long they accelerate, he sees them approach the speed of light. Now, the important thing about this is that what will happen if the spaceship turns its headlights on? And I think what will happen is the headlights, even if this spaceship is now going from its own point of view 5 or 10 times the speed of light, so let's say 5c, they've been on the road for 7 years, accelerating at one gravity. And let me digress here and say, Dr. Learned, that it would be interesting to find out how long it would take to get here from the center of the galaxy if you had the capability to continuously accelerate at 10,000 gravities or 1,000,000 gravities. But in any case, at one gravity, for 5 years, you're now going 7c. You go for 7 years at one gravity, you're now going 5 times the observed speed of light from your own point of view, 99.999 from the point of view of somebody watching it from Earth. Now, what happens if the guy behind you, who's trailing you, turns on his headlights, and you look in your rearview mirror? What will you see? And it's my speculation and understanding that even if you're going 5c, 5 times the observed speed of light from your own point of view, the guy trailing you, also going 5c, following you, when he turns his headlights on, your experience is going to be, you're going to see those headlights that you, just like he was right behind you on a road on Earth. In other words, even though he's going 5c, when he turns his headlights on, those headlights are going to hit you, and you're going to experience them just as if you were standing still on Earth. So that means the actual speed of light emitted by this guy's headlights is way, way, way faster. My suspicion is that if you're going 5c this way, and this guy's going 5c that way, both the same direction, he turns his headlights on, the light from his headlights is going to zip past your ship at the same speed it would as if you're standing still. You're going to observe it as being going at the observed speed of light. He's going to observe it going at the observed speed of light. And the guy back on Earth is going to observe that light going at the observed speed of light. And yet we know that this guy's going 5c, this guy's going 5c, and these headlights are going faster than that. So the reality is that the actual speed of light is far, far, far faster.